So we have to calculate the frequency. Frequency. So waveform are given. RMS value times 0.02 second. D equal to 0.202 second. So that we calculate the frequency f equal to 1 by t. So 1 divided by 0.02. So we got the frequency is 50 hertz. The next problem, we also need to calculate the frequency times 0.03383 second. T equal to 0.0833 second. So frequency can be calculated 1 divided by 0.0833. So the frequency value is 12 hertz. Also the 1 millisecond equal to 1 millisecond. So frequency can be calculated f equal to 1 by t. 1 millisecond 10 power minus 3. So that will be 10 power 3 hertz or 1000 hertz. So this is the way that we calculate the frequency. Then also we need to calculate the 0.05 millisecond equal to 0.05 millisecond. Frequency can be calculated 1 by t. So 1 divided by 0.05 into milli is 10 power minus 3. So this is 10 power 3 divided by the 0.05. So that will be the 0.05 divided by 0.03. So that will be 1 divided by 0.05 into 10 power 3. So that will be the 20 into 10 power 3. So the 20 kilohertz. Those are the frequency of the waveform. Times are given from the time. We can calculate the frequency value. Okay, now that we get the maximum value. So V maximum is a 120 volt. Maximum value is 120 volt given. So we have to find out the waveform here. So there is a degree. Here degree. Here is a sine value. Here is a voltage value. Degree, sine value, and the voltage values are given. So maximum voltage is 120. Now the sine value and the voltage value we can put into this graph, this table. So degree is given as 0, 15, 30, 45, 60, 75, 19, 105, 120, 135, 150, also given the another table here, degree, sine value, and voltage value. So another table here. So degree given that 165, 180, 195, 210, 225, 270, 285, 300, 315, 330, 345, and finally 360. So those are the degree values given. So based on the degree value, maximum voltage given, maximum voltage is 120 volt. So the big 120 volt multiplied with sine. This voltage equal to the V maximum sine theta. So sine value you multiply, then this voltage value we can calculate. So maximum voltage 120. So sine 0 is 0, sine 50. Sine 15 is 0 by 258. Sine 30, 0 by 5. Sine 0 by 0 by 707. Sine 60 is 0 by 866. Sine 75. Zero by 965. Sine 98 1. Sine 105. 0 by 965. Sine 120. So 0 by 866. Sine 135. 0 by 707. Sine 150. 0 by 5. And sine 165. 0 by 259. Sine 180 is 0. Sine 195. So minus 0 by 258. Minus 0 by 259. Sine 210. Minus 0 by 5. Sine 225. Minus 0 by 707. Sine 270. Sine 240. Sine 240. Sine 255. Sine 255. And sine 270. Sine 285. Sine 300. And sine 315. And sine 330. And sine 360. So those are the sine values. So the sine 240 we calculate. So minus 0 by 866. Sine 255. So minus 0 by 965. Sine 270. So minus 1. Sine 285. Minus 0 by 965. And sine 300. minus by 0.5 sine 300 minus 0.866 sine 315 minus 7.07 and sine 330 so the minus 0.5 sine 3 is 0. So those are the value of the angle, sine angle. So that we multiply 120 is 0 is 0. 120 multiplied by 0.258. So that 30.96. And this is 60. 120 multiplied by 0.707. Here is 84.84. And 0.1866. 120 multiplied by 866 is 104. And 0.965. So 115.8. So this is a 120. So this is a 115.8. Here is 104. Here is a 84.8. Here is 60. And 165. There will be the 30.96 and 0. Here is a negative 30.96, negative 60, negative 84.8, negative 104, negative 115.8, negative 120. So this is 0.966, so negative 115.8, negative 104, negative 84.8. So negative 60 and 0. Those are the value. And below the 360, they are 360, so 345. So the side 345. So negative 258. So this is negative 258. Negative 30. 30.9 and the 0. Those are the side values are given. So based on the here, now we can plot the graph. Graph can be calculated. So there will be the, this is voltage V, this is 0, this is minus V. And we can put 0, 15, 30, 45, 60, 75, 90, 105, 120, 135, 150, 165, 180, 195, 210, 225, 240, 255, 270, 285, 285, 300, 315, 330, 345, and 360. So those are the angle value and magnitude values that we provided. Then based on here, we can start plot the graph. Okay, so the positive to negative, we find out the voltage magnitude. So that will be 0. Then we base on here. So the maximum value is at 90. So that will be the go to the 120. And then voltage will be going down. That one is 0. And then this one will negative cycle here. 270 maxima. Then go down, and go back to the 360. So this is the way we practically calculate, and we can plot the graph. So this graph we can calculate. We need to draw the phasor diagram of the voltage value. So in this case, V1 240 volt, V2 180 volt. V1 240 volt, V2 180 volt. V1 240, V2 180 volt we got. V1 lead the V2 by 50 degree. V1 lead V2 by 50 degree. So in this case, we can draw the diagram. How we draw the diagram? Here we can draw the horizontal line. This is a reference line. V2 is 180 and 50 degree. V1 50 degree, so you can measure the 50 degree. So this V1 is here. V1 lead the V2 by 50 degree. V2 value is we can put 180. V1 is 240. So this angle is lead the V2 by 50 degree. The next one, we can also draw the two current. I1 value, I1 is 2.5 ampere. I2 is 3 ampere. And I3 1.75 ampere. So three currents are given. I1 is 2.5 ampere. I2 is 3 ampere. I3 is 1.75 ampere. So the I1 lead I2 by 30 degree. I1 lead I2 by 30 degree. Then I3 lead I2 by 45 degree. So the I1 lead I2 by 30 degree. I3 less than I2 by 45 degree. Those are the given. So that we have to calculate. In this case, I1 lead I2, I3 let the I2. So that we can take this I2 as a reference. The horizontal line, this is the I2 is a reference. So the I2 value we calculate is 3 ampere. And this is for the leading is this way. Here is a lagging. So this is leading, this is lagging. So the I1 lead the I2 by 30 degree. So this is the 30 degree. So this is I1. I1 value is 2 by 5 ampere. I3 let the I2 by 45 degree. So here 45 degree. So we can draw that this is I3. I3 is a 1.75 ampere. So this is the way we can draw the Vector diagram. So this is I2 reference. I1 lead the I2 by 30 degree. I1 value is 2 by 5 ampere. I3 let the I2 by 45 degrees. So I3 value is a 1.7 ampere. This is I3 1.75 ampere. So this is the way we can draw as a Vector diagram. Okay, the next problem. Here are the diagram here. There will be the two I1, I2, and the I3. Two vector. So we can draw this one. So that in this case, how we can do is the vertical represent the voltage. So we can multiply with the voltage value is 4 bar division multiply number of division. So this is a 4 bar division multiply number of division. Horizontal. Horizontal is we can have to here is 180 degree. One way point going 180 degrees. So you can calculate how many is this is a time bar division. So number of division. So that time related to the 180 degree. So this is the ways of horizontal and the vertical relationship. Vertical 4 bar division multiply number of division. Horizontal time bar division multiply number of division. So that time to complete the one waveform is 180 degrees. So this will be the 180 degree we can calculate. Okay, this is the next problem. Next problem we can see the waveform. This is a waveform given. So waveform are given. So based on the waveform, we have to calculate. So there was a waveform. So this two waveform. So V1 and V2 value. So two waveform are given. This is for the V1, this is the V2. V1, V2s are here you can see. So in this case, you can see the time observation. Voltage observation 10 volt, time observation is 5 milliseconds. So voltage observation 10 volt, time observation 5 milliseconds. Voltage observation is 10 volt, time observation given at 5 milliseconds. So that now we can calculate how many are V1, how many division. 1 division, 2 division, 3 division. Therefore, V1 maximum value here you can count horizontal line 1, 2, 3. So this is V1 maximum 30 volt. Because of the each division got a 10 volt, there are 3. So that will be 3 multiplying 10, so you got a 30 volt. V1 is a 30 volt. We can calculate because of the you can see here 1 division, 2 division, 3 division. 3 division multiply 4 division 10 volt, so that will be 30 volt. V1 30 volt. V2 how many division? 1, 2, 3. So that will be around the 3.6 division. So this is V2 3.6 multiply 10 division, that will be the 36 volt. V2 is 36 volt. V1 30 volt, V2 36 volt. Therefore, we can calculate V maximum, V1 P2P. So P2P is here. P2P is 2 times V maximum. So 2 times 30, 60 volt. V1 P2P is 60 volt. V2 P2P. So the V2 P2P is a V2 values are we already know it. V2 is a 36 volt. 36 multiplied 2, you got a 72 volt. V2 P2P is 72 volt we calculate. So V1 P2P is a 30 volt, V2 P2P is a 72 volt. Then we also need to calculate for the how many phase difference. So how many phase difference you can see how many phase difference. So this is the 1 division, 1.5 division because here step from the V1. This one 1 division, 1.5 division. 1.5 division is phase difference. 1/5 division phase difference. 1/5 division is phase difference. So 1/5 division phase difference. So one cycle, how many times, how many division? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So just see that the V1 we find here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 division, one cycle. One cycle, 10 division. So that those information now we can utilize and calculate. So this is why I show you about the graph. We can take out the relevant information. So now that we can see the how many phase difference because of the V1 here and V2 here. Here phase difference is a 1/5 division. And V1 here to here, how many division? 10 division. So we need to calculate the phase difference. So there will be the 1 division is 5 milliseconds. So this is a 10 division is this time time can be calculated 5 milliseconds into 10, so this is a 50 milliseconds. This 50 milliseconds is, here is 180 degree. So that will be, we can calculate, no? 50 milliseconds related to the 180 degree. Now 1/5 division, phase difference 1/5 division, how many seconds? So the phase difference 1/5 division, 1/5 multiply 5 milliseconds. So 7.5 milliseconds. 7.5 milliseconds. We calculated 50 milliseconds is 180 degree. 7.5 milliseconds, how many degree? So 180 multiply 7.5 divided by 50. Then we calculate 150 multiplied by 7.5 divided by 50. 180 multiply 7.5 divided by 50. So you got 27 degree. Phase difference now we calculate is at 27 degree. So this waveform V1 and V2, here V1, V2, their phase difference is at 1/5 division. From the graph, from this graph we can count, we know the phase difference. As I show you from this graph, we can count 1.5. Phase difference is 1.5. So this is the way we calculate the phase difference. Phase difference is a 1.5 division. So the 1.5 division is equivalent to the timer division 5. So the 1.5 multiplied by 5, 7/5 is a millisecond. And to complete the one cycle, how many waveform? To complete the one cycle, how many division? So you see the V1 here, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 division is required to complete the 180 degree. This is here 90 degree. Here is a 360 degree. Sorry, not 360 degree. Yeah, 360. So definitely this will be the 54. Because one cycle is a here is a 180. 180. Here is a 360. So 360 degree. 360 degree is required to complete one cycle. So 50 milliseconds, 360 degree, 7.5 milliseconds. So 360 multiplied by 7.5 divided by 50, you got a 54 degree. So this waveform is a phase difference is 54 degree. We calculate this phase difference is 54 degree. From here, we can calculate the phase difference is 54 degree. In the meantime, we also need to calculate what will be the 54 degree difference. Also, we need to calculate VIF. So V1 IF. V1 IF is the V maximum divided by 1.4142. So or the root 2, so the V1 maximum is 30 divided by the 1.4142. So you can calculate V1 30 by 1.4142. So that way 21.24. V2 max IMS. So V maximum divided by 1.4142. V maximum 36 divided by 1.4142. So 36 divided by 1.4142. You got 25.45. So V1, V2, we can calculate. The phase different angle is, we can calculate the 54 degree. Then we draw the phasor diagram. So V1 is a leading. V1 coming first and V2 coming second. Therefore, the V1 value, IMS value is 21.2 volt. This is the V1. V2 is 54 degree lagging. V2 value is here. This is a 25 by 4. So this is a V2. So beta will go in this way. This is the way we can draw the beta diagram. So V1 horizontally 21 by 2 and lagging. We do it lagging, so 54 degree lagging. So we can draw a 25 by 45 and we can draw the beta diagram. Therefore, if you see the waveform like this, we can change to the beta diagram like this. So that if you see the waveforms are given like this. Based on the waveform, we calculate the phase difference. We calculate phase difference and angle. We can calculate. So firstly, we calculate the time. We count the deviation. How many deviation different? Once our circle is here to here 360 degree. Here to here 360 degree. So how much is this angle? So they are 10 deviation is a 360 degree. So 1 by deviation, then we can calculate 54 degree. And then based on the 54 degree, we can now calculate, we can draw the beta diagram. So V1 is horizontal, V2 is lagging. So this is V2 is coming from here, is a V2 is lagging. V2 lagging means the V1 horizontal line and 54 degree, and we can plot the V2 value. V1 21 by 2, V2 25 by 45. Then we can draw the phasor diagram. By this way, we can draw the phasor diagram like this. So this means that if you see the waveform, we can change to the phasor diagram like this. The next one. The next one is we can provide heating element connected in parallel to 240 volt supply, single phase motor. The current drawn by the heated element 10 ampere. In phase with the supply voltage, current drawn by motor is 7 ampere. Let the supply voltage by 30 degree. So this is a two element. This is supply voltage given. Supply voltage is given is 240 volt. The active, this is neutral. 240 volt. Supply voltage is at 240 volt given. So that we can connect the two loops are connected. Here is heater. Here is a motor. Heater and motor are connected in parallel across a 240 volt supply. So in this case, heater draw a 10 ampere. Motor draw a 7 ampere. For the heater got the only resistance. Therefore, is in phase with the voltage. But the motor is 70 degree lagging. Voltage motor current is a 70 degree lagging. So we have to draw the phasor diagram. So in this case now we can draw. There will be the reference. Supply voltage 240 volt, we can take the reference. So V equal to 240 volt if we take the reference. Current 10 ampere in phase. So this is the heater. Then 70 degree lagging. So we measure 70 degree. Motor current 7 ampere. So this is for the phasor diagram. And then we can need to draw the current from the supply. Here is the current drawn by supply. Combination. So here to here, this is supply current. We have to calculate the supplying current. In this case, we can write the equation. This supplying current is a two vector like this. Vector 1 V1, vector 2 is V2, angle is theta, this is Vd. If you see this circuit like this, in this case, Vd can be calculated. Vd is square root of V1 square plus V2 square plus 2 V1 V2 sine theta. V1 V2 cos theta. V1 square plus V2 square plus 2 V1 V2 cos theta. So this is a formula. And therefore, here you can see I1 10 ampere square, 10 square. This is I2 is a 7 square. 2 into I1, I2 is 10 multiply 7. And cos angle is a 70 degree. So this is the way we calculated cos rule. So that we solved this problem. So there will be 100 plus 49 plus this is 140 cos 70 degree. So 0.342. So by solving this one, what you got is 140 multiplied by 342 plus 149. 196.88. So square root. There will be the 14 ampere. 14 ampere we got. And we also need to find out this angle. Angle phi. So angle phi we had to find out. Now, this magnitude is here we got the 14 ampere. Here is 7. Here is 10. So this diagram. Here 70 degree. So this angle can be calculated. This angle is 180 minus 70, so you got 110 degree. So this one 110. This value is 14. This is 5. This magnitude is 7. This one is 10. So we write down this equation sine formula. So there will be according to the sine rule. You see the sine rule here. This is A, B, C, alpha, beta, phi. So according to the sine rule, we write down here. So A, this is B, C. So A by sine A equal to B by sine B equal to C by sine C. So this is a sine rule formula. A by sine B equal to B by sine B equal to C by sine C. So this similarly this equation here. This is for the phi. We don't know the phi. Opposite side is 7. So the 7 by sine phi. 7 by sine phi equal to 14. 14 by sine 110 equal to. So this is 10. 10 by this 4 is a sine theta. So this is sine alpha. So 10 by sine alpha. So that we only have to concern about this one. 7 by sine phi equal to 14 by sine 10. So this is the way we calculate. So the cross multiplication. 7 sine 110 equal to 14 sine phi. So the sine phi equal to 7 sine 110 divided by 14. So we calculate sine phi. Sine 110 0.939 multiply 7 divided by 14. You got 0.465. Sine is 0.469 degree. Sine phi 0 by 469 degrees, so we find the sine inverse. Inverse sine by 469, you got 29 by 76. 27 by 96. 27 by 90 degree we got. So this is the phase angle like we can find out. So this one, so firstly, this equation here, we write down as this component, Vd equal to square root of V1 square plus V2 plus 2V1 V2 cos theta, that equation. So similarly here, this is the 10. So 10 square plus 7 square plus 2 into 10 multiplied 7 into cos 70 degree. Then we can calculate the total current, total Vd is, total current is ID, no? ID we can, this is ID, no? This is ID, this is Vd. So ID we can calculate, no? This way. So there is a 40 ampere. So this triangle, so 40 by sine 10 equal to sine 110 equal to, this is a 7 by sine 5. From here you can find out the 5. Because of the, this angle is a 70 degree. This is 70 degrees, so this is also 70 degrees. So this angle is 110. Because 180 minus 70, so you got 110. So this 110. So the 40 by sine 110 equal to 7 by sine 5. Then we can calculate the phi value. So this is the way phi equal to 27 by 96 degree. So the total current is 40 ampere, angle phi is 27 by 96 degree. Okay, the next one, capacitor in series with resistor. Capacitor is connected in series with the resistor. This is resistor and this is capacitor. Capacitor connected in series with the resistor. Voltage across the capacitor 190 volt. So this is a VC 190 volt. Voltage draw across the resistor is 147 volt. So the VR 147. VC 190, VR 147. So that we can draw the diagram. Voltage draw across the capacitor and voltage draw across the resistor. So therefore the resistor voltage is 147 VR. Capacitor voltage is a leading resistor, so the VC 190. So this is the phasor diagram. Then we need to find out the supply voltage V total. So we write down the equation. V total equal to square root of VR square plus VC square. Because of the Pythagorean theorem, this one, so this way there's a supply voltage. So that way we substitute. VR is a 147 square, VC is a 190 square. Then we can calculate the supply voltage. So the 147 square plus 190 square. Square root, you got 240 by 2. 240 by 2 volt. So supply voltage is 240 by 2 volt. And also then we do find out the angle. This angle phi. Phi need to find out how much angle is leading. So this one is a going like this, a leading. So that this phi, tangent phi, can be calculated opposite side divided by adjacent side. So opposite side is VC is the opposite side, VI is the adjacent side. So VC by VR. So the VC is 190, VI 147. So 190 divided by 147, we calculate tangent phi. 190 divided by 147. So we got 1 by 29 value. So the phi can be calculated tangent inverse 1.29. Tangent inverse 1.29, so this angle calculates, so the inverse tangent 1.29, so we got 52.2 degree leading. So the angle is a total current magnitude is total voltage magnitude is 240 volt. Angle is 52.2 degree leading. So this is how we calculate it. The next problem. A 240 volt 50 Hz single phase motor draw the 18 ampere from the supply. Lagging phase angle 40 degree. So the motor current IM. Motor current is drawing the 18 ampere from the supply and lagging 40 degree. Motor current 18 ampere from the supply and 40 degree lagging. Then we connect the capacitor. Capacitor connected across the motor draw a 7 ampere leading phase angle 90 degree. So the capacitor IC. IC draw the 7 ampere and 90 degree leading. So this is the information given. So this problem here is the supply. Here is motor. Here is capacitor. So this is the IM flowing in this direction. IM here. This is the IC here. IM is a 40 degrees lagging. IC is 7 ampere and 90 degree leading. So those are given. We have to draw the current from the supply. I told them we had to be calculated. Then we had to draw the vector diagram. So that this is the horizontal here. IM is 40 degree leading. So this is IM. IM 18 ampere. 40 degree lagging. IC 7 ampere. 7 ampere 90 degree leading. So we have to find out total current. Parallel diagram here. Then we do the current ID. ID had to be calculated. So this angle, similar to this angle here, this is the 90 plus 140 is a 130 degree. Here 7, here is 18. So we make a parallel correlation. There is a PD supply. So we, this is the I total supply. I total is a total current. So we write down the equation. I total equal to square root of IM square plus IC square plus 2 IMIC and cos 5. This is how we calculate. So this is the we substitute the magnitude. IM motor current 18. Capacitor current 7. 2 multiplied by 18 multiplied by 7 and cos 130. So this is the way we calculate total current. So the 130 cos 130. So minus 0.642 multiply 2 multiply 18 multiply 7. So this is a 161.9. Here is 18 square plus 7 square 373. So 373 minus 161.9 and square root. That will be there 14.5 ampere. So this is for the total current is 14.5 ampere. And then we also need to find out the angle. So how much angle? This angle need to find out. So this angle. This angle is, you can see there. So this will be here. This is I total. Here is a 7. Here is 18. So 7 is a IC value, 18 is a IM value. So this angle here. So this one need to find out. This is angle theta. ID magnitude is 14.5. So those be our magnitude given. So this angle is a 130. So because of this one is a 90 plus 40, 130. So this was also the opposite 130 degrees. So that we write down the equation, use the sine rule. 18 by sine 130 equal to 7 by sine theta. Then we can find out the 7 theta. So 18 sine theta equal to 7 sine 130. So sine theta equal to 7 sine 130 divided by 18. Then we can find out the angle theta. So the sine 30, 130 multiply 7 divided by 18. So 0.297. And angle theta can be calculated. Sine inverse 0.297. So the inverse sine 0.297. So you got angle is 70.2 degree. So this is the way angle we can calculate the supply current angle. Okay, the next one will be the next problem. $20 ohm resistor. Draw the 60 ampere from the AC supply. So resistor is at 20 ohm. It draw the 60 ampere from the AC supply. So resistor 20 ohm. The current flow is 60 ampere. So resistance got the 20 ohm. The current taken from the supply is 60 ampere. So we have to calculate the voltage. Voltage can be calculated I multiplying R. So I 16, R is 20, so you got the 320 volt. Voltage is at 320 volt we calculate. We also need to calculate power. Power equal to, we calculate the voltage into current, V into I. is a power. So voltage is a 320, current is 16. 320 multiplied 16, we can calculate the power. So that 320 multiplied 16, you got the 5120 watt or 5.12 kilowatt. This is for the power we can calculate. This problem. The next problem. Heating element is connected to the 240 volt supply. Radiant heater is 1.5 watt. We have to find out the current. So that when you connect the heater to the electrical circuit, so that will be voltage is a 240 volt. Power 1.5 kilowatt. We need to find out the current. For the heater, power can be calculated voltage multiplied current. So the current can be calculated power by voltage. So power is 1.5 into 10 power 3 divided by 240. Then you got the current. So I go to P by V. So the 1500 divided by 240. So you got is 6.25 ampere. Current is 6.25 ampere. We calculate. The next one. In this case, a capacitor given 47 microfarad capacitor connected to the 32 volt. We have to find the capacitive reactance. So capacitive reactance need to be calculated. In this case, capacitor value. This is a capacitor value. Capacitor is given the 47 microfarad. Supply voltage is 32 volt 50 hertz. We need to calculate AC. So across to AC, AC equal to 1 divided by 2 pi FC. Pi and the F is the frequency. Then we substitute here AC here. So 1 divided by 2 pi 3.1416, frequency 50. Capacitance value is 47 microfarad. So 47 to 10 power minus 6. So that will be 10 power 6 divided by. So 314 plus 3, this is the 314 multiplied by 47. Then we calculate the AC. So 10 power 6 divided by 314 divided by 47. So you got 67.75. Oh. So that will be the system capacity reactance is 67.70. So in this case, you can also find out the current. How much current from the supply? How much current taken from the supply? You can also calculate. IC need to be calculated. Voltage divided by AC. The voltage is 32 volt. AC is 67.75. Then we can calculate the current as well. 32 divided by 67.75. So you got is 0.472 ampere. So this is the ways we calculate the capacity reactance, and also that we can calculate current drawn from the supply. This is the way we calculate that. Then another thing is that we connect the capacitor. We connect the capacitor to the 240 volt 50 hertz supply. It taking the 3 ampere. So this is the capacitor, 240 volt and 50 hertz supply. The capacitor is taking the currents are 3 ampere. We need to find out capacity reactance and capacitance value. So the capacity reactance can be calculated AC equal to V divided by IC. The voltage 240, current 3, so you got the 80 ohm. Capacity reactance 80 ohm. Then we substitute the formula. AC equal to 1 by 2 by FC. So therefore C can be calculated 1 by 2 by F into AC. So here 1 divided by 2 is a 3.1416, frequency 50. and AC value is 80. So the C can be calculated this way: 10 power 6 divided by the 314.16 into 80. So this is microfarad. So 10 power 6 divided by 314.16 divided by 80. So you got there 39.78 microfarad. The capacitance value is 39.76 microfarad we calculated. The next problem, capacitor take the 6 ampere connected to 240 volt supply. How much current capacitor will take from the 115 volt? So in this case, this problem here. In this case, this capacitor we connected to here supply. This supply is a 240 volt supply. In this case, current take the 6 ampere. Here AC, so that then we can calculate the AC value. AC equal to V by IC. So voltage 240, current 6, so you got a 40 ohm. AC 40 ohm we can calculate. And then we change this one to the supply. So this capacitor AC is 40 ohm and supply voltage is 115. We need to find the IC as well. So IC can be calculated 115 supply voltage divided by 40. 115 divided by 40, we calculate the capacitor current. So this is 115 divided by 40. So it will be there 2.875 ampere. So the current we can calculate like this. Okay, the next problem. So this provides that if you connect the resistor to the AC supply, resistor only behave as similar to the DC. So there are two resistors we connected here. Resistor R1 and R2. Supply voltage 24 volt. So resistance R1 is 418. So we have to find out the I1 current 5 ampere, I2 is 7 ampere. Here I1, I2. I1 is 5 ampere, I2 is 7 ampere. So we need to find the resistance. R1 can be calculated. R1 is a V by I1. So voltage 24, I 5, so you got a 4 by 8 ohm. R2, V by I2. Voltage 24, current is 7, so you got, that will be the 3.43 ohm. So R1, R2 value, we can calculate like this. And we also need to find out the equivalent resistance, R total. R total is 1 by R1 plus 1 by R2. So the 1 by R1 is a 1 by 4 by 8, 1 by R2 is 1 by 3 by 43. So this is 1 divided by 1 by 4 by 8 and 1 by 3 by 43. So 1 divided by 4 by 8, so you got that thing is 0.208. 1 divided by 3 by 43. So you got 1 divided by 3.43. That will be 0.2915. So there, plus 0.208. 4995. So that will be total resistance. Has to be calculated. That will be the 1 by 0.5. So this is 2 ohm. Total resistance is 2 ohm we calculated. Power dissipated by the E resistance need to be calculated. So the P1 can be calculated. Voltage squared divided by resistor R1. Voltage 24 squared by resistor R1 is 4 by 8. So 24 squared divided by 4 by 8. This is 121. Power P2. Voltage squared divided by resistor R2. Voltage 24 square, resistor R2 is 3.43. So 24 square divided by 3.43. So this is it. 169 watt, 168 watt. So this is the way we calculate the power P1 and P2. The next one is another problem. Now we connect the capacitor. Capacitor in parallel, we connect to the AC supply. So this is the capacitor. Capacitor C1, capacitor C2. They are connected parallel. We connected to the AC supply. AC supply is 240 volt, 50 hertz. Capacitor I1 current. Capacitor C1 current is a I1. Capacitor C2 current is a I2. So I1 is given 4.22 ampere. I2 given the 2.94 ampere. I1 4.22, I2 2.94 given. So we have to calculate capacitive reactance. So the HC1 V by I1. Voltage 240, I1 is 4.22. So capacitive reactance C1 is HC1. So the 240 divided by 4.22. So you got there 56.8. Oh. Then we calculate the capacitance value. So capacitance value can calculate that C1 equal to 1 divided by 2 pi FHC1. So 1 divided by 2 into 3.14 into 50 into 56.8. So that this will be the, so that will be the farad. So that that will be, and then more 6. So we can calculate microfarad. So the 314 into 56.8. So the C1 value can calculate that. Divided by 314 divided by 56.8. So there will be 56 microfarad. And C2 also calculated. C2 equal to 1 divided by 2 into 3.14 into 50 into capacitor reactance C2 also need to calculate that. So the HC2. HC2 is supplying voltage 240. The current is at 2.94. So that this is 240 by 2.94. You got the 81 by 6 ohm. So C2 is at, when you CPU 81 by 6. So this is 10 power 6. So this is a microfarad. So the 10 divided by 314 divided by 81 by 6. That will be you got 39 microfarad. So this is the way we calculate that. And then we also need to calculate the capacitance, total capacity reactance. So the two capacitors are connected in parallel. We can write down C1 plus C2. So C1 is 56, C2 is 39. So this will be the 95 microfarad. And power is 0 because of the capacitor dissipated. Zeros are power. So that will be, so the capacitance is 95 and the power is 0. So the capacitance 95 microfarad and power is 0. Because of the capacitor drawing the zeros are power, reactive power, so therefore the power is 0. The next problem is coil. Coils are inductive reactance calculated 2 by Fl. So this is a A is a frequency, A is an inductance, unit is a Henry. A is a frequency, A is a inductance unit in Henry. So we solve the one problem. When connected to 240 volt 50 hertz supply, ID inductor draw the 1 by 2 ampere, we have to find out the reactance. So this means this is for this one here, we connect the 240 volt supply. Current is 12 ampere. So we need to find out the reactance, inductive reactance. So HL can be calculated, voltage divided by current. Voltage are 240, current is 12, so you got the 20 ohm. So this is the way we calculate it. The next problem. Equal of negligible resistance, inductance are 0.05 Henry. We have to find out the inductive reactance at the 50 hertz supply, at the 33 hertz supply, and the 1 kilohertz supply. So in this case, HL can be calculated. Equation is that HL equal to 2 by FL. That equation. So if you connect the 50 hertz supply, so 50 hertz, HL can be calculated. 2 into pi is 3.14, frequency 50, inductance value is 0.05 Henry. So by solving this one, that would be 15.70. And if you connect the frequency is 33 hertz, so HL can be also be calculated. 2 into 3.1416 into 50, it's a number 33, multiply 0.05. So that will be 10.40. And also the 1 kilohertz. So HL can be calculated 2 into 3.1416, 1 kilobyte is 1000 multiply 0.05. So that will be 3140. So that way we calculate for the inductive reactance at a different frequency. Although the inductance value is not changing, uh, due to this effect, due to the effect of the frequency, the inductive reactance is changing. So this is how we can calculate inductive reactance. The next problem, inductor is at 153 millihenry connected to 240 volt. Instead, connected to the 200 volt, we have to find out the current. So this condition, so first these are 153 millihenry. We connect it to 240 volt. We need to find out the current. So firstly, we have to calculate the HL. So 2 by FL. 2 into 3.1416 into 50, 153 into 10 power minus 3. Then we calculate the HL value. So this is the 314 multiply 153 divided by 1000. So this is 48 ohm. Where did we calculate? Then we calculate the current I, 240 divided by 48 ohm, got a 5 ampere. And also we connected to the 200 and 400 hertz. Now the 400 hertz. So 400 hertz HF value can be calculated. So 2 into 3.14 into 400. Into the 153 millihenry, so 10 power minus 3. So this is we calculate 2 multiply 3.14 multiply 400 multiply 153 divided by 1000. So you got 384.30. Then current can be calculated. 240 divided by the 384.3. 240 divided by 384.3. So this is the 0.62 ampere. If supply voltage is a 200 volt, 400 hertz, how much? So in this case, I can also calculate 200 divided by 384.3. So you got that 0.52 ampere. So this is the ways we calculate. So in this case, inductive reactance is depending on the frequency. When you change the frequency, inductive reactance will be changing. So the supply voltage divided by inductive reactance, we can calculate that current. How much current from the supply and drawn from the supply we can calculate. Then the next one is the series AC circuit. Series RLC circuit. So series series RN RC circuit